Okay, so in this video we're going to talk a little bit about writing equations, in particular molecular, ionic and net ionic equations. And we're going to use as an example, let's say we have sodium chloride here. Okay, sodium chloride dissolves in water, so that's aqueous, and then we have lead 2 nitrate here. Both of these are soluble salts according to the solubility rules. And so the first thing we need to figure out is what are the products, what exactly goes here. And so we just have to remember what sort of reaction we're going to be doing here. Well, we have one species here, which is the sodium chloride. We have another one here, which is the lead 2 nitrate. And if you remember, when you have two species like this, particularly two soluble ionic compounds, this is going to be a double displacement reaction, also known as a metathesis reaction. But double displacement is easier to remember because each of your metals essentially displaces the anion and then grabs the other one. So for example, the sodium originally was with the chloride, the sodium then goes with the nitrate over on the product side. The lead 2+ was originally with the nitrate, and over in the product it goes with the chloride, the Cl-. So like I said, first what we need to do is just to make sure that we write the equation out. So we know that one of our products is going to be sodium nitrate, NaNO3, and according to our solubility rules, again, that is soluble. You're going to find that in reactions like this, and in questions like this, there may be one or possibly two products that are insoluble. And it turns out lead and chloride, when they go together and they form PbCl2 from Pb2+ and Cl1-, just like so, what we find is that lead 2 chloride I should say, is actually insoluble. And so of course it gets the designation of solid. So at this point you might be wondering, well, okay, is that my reaction now? I've got to figure out all this molecular ionic and net ionic stuff, whatever that means. But there's actually one other thing that we need to do at this point. And I wonder if anybody can figure out what that other thing is. Well, of course, what that thing is the fact is our equation isn't balanced. So where should we start off? Where should we start off? It doesn't really matter where we start. Let's start in sodium chloride. We've got one sodium, one chlorine, one sodium. I've got two chlorines here, so I can balance that by putting a 2 here. I also have two nitrates here and only one here, so if I put a 2 here, you'll actually see that everything is balanced. So that's my balanced equation. So now we're going to deal with these three, molecular, ionic and net ionic equations. Now the first one, the molecular equation, is the easy one. It's just the molecules in their standard form, so exactly as we have shown here. So this is our molecular equation because all of our species are shown as molecules. Okay, but the fact is, and this is an important thing to understand, ionic, 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 ionic. Ionic insoluble, ionic insoluble, ionic insoluble, and ionic insoluble. So I have three species that are soluble, three ionic compounds that are soluble. And I'm sure everybody knows what happens to an ionic compound when you put it in water, assuming that it dissolves. Those two ions don't stay together. Well, okay, a small number of them do, but the vast majority of them get separated. And that's what we're going to look at when we draw out our ionic equation. We're going to write all the species out that we have to, that are actual ions. There is only one of these four species that we don't write out as ions, and it's the only one that in fact does not separate as ions. And that's the species that doesn't separate because it doesn't dissolve. So the PbCl2, or any solid ionic compound, is that way because these ions don't separate. So PbCl2 solid in the molecular equation stays as PbCl2 solid in the ionic equation. So let's say sodium chloride. We know sodium chloride splits up into Na+ and Cl-, but we have two of each here. So we're going to say, now this is going to take up a little bit of room, so just be prepared for that. 2 Na+, And we have to make sure we put on the states of each thing here. 2Na plus 2Cl minus, that's also aqueous. That's my sodium chloride all split up. And then I have my lead as well. We said before the lead was 2 plus, so that's Pb2 plus. That's also aqueous again because lead nitrate is soluble. And we have 2 nitrates from that NO3 2. Nitrate of course has a charge of -1. As we said before, that's also aqueous. Now let's look at the products that we get. We also have 2Na plus here. 2Na plus, and again there is aqueous. Okay. And we have 2NO3 minus aqueous. Okay. Should have given myself a little bit more room here. And then we have our PbCl2 that didn't really do anything. So we're going to leave it the way it was, plus PbCl2 solid. Okay. So that is the net ionic equation, preferably all on one line. And then, well, sorry, that's the ionic equation. Now when we get to the net ionic equation, this guy right here, what we're looking for is something called spectator ions. Spectator ions. Alright, spectator ions. So when you guys go to a football game or soccer game, if any of you do, a basketball game or whatever, you can call yourself one of the spectators that sits in the audience and just watches what's happening. And that's exactly what we're looking for, except these are ions that are spectating. Alright, so what we're looking for is the ions that are present on both sides of the equation, because really all they are is they're just onlookers watching what's actually happening, because the actual reaction doesn't involve them. So let's take a look. We have 2Na plus on the reactant side and 2Na plus on the product side, so I'm going to cancel that out and that out. Now you guys don't have to cross these out when you're doing questions like this. I'm just doing it so you can see what's happening. I have Cl minus on the end, I've got no Cl minus on the product side. I've got Pb2 plus on the reaction side, I've got none of that on the product side. You remember, you have to have your species be exactly the same. But I do have 2 nitrates on the reaction side and 2 nitrates on the product side, which actually means what I'm left with is 2Cl minus aqueous plus Pb2 plus aqueous makes PbCl2 solid, and that is the overall reaction. Because, oops, I'm trying to draw a box here, it's not working quite so well. This is the overall reaction because these are the only things left after you get rid of these spectator ions, and that is how you go from completing a reaction. You remember we said this was a double displacement reaction, to writing out the ionic equation, to writing out the net ionic equation, and that is how it works. Thank you. I'll be here all week.